Dear participants, mute your call.
Mute your call.
Dear participants, mute your call.
Pandisalvi ma'am.
Ma'am?
Ma'am, start the session. It's
Okay,
time.
ma'am. Yes, ma'am. Good evening, everyone. We welcome you all to the day three of our FDP. Over the past few days, we have gained remarkable insights into artificial intelligence, generative and agentic AI, and AI attacks, digital transformations, and related to cybersecurity. Today, we explore various emerging trends, innovations, and practical applications that are refining the future of intelligence systems. It is now my pleasure to invite Ms. B. Meenakshi, Assistant Professor, Department of Computer Science, to introduce today's esteemed resource person.
Thank you, ma'am. Good evening to one and all present here. It is very great pleasure to welcome you all to this esteemed occasion. I am happy to extend a warm welcome on behalf of Mangayarkarasi Management. I heartily welcome our respected Principal, Dr. Uma Bhaskar ma'am, respected Dean Chandu Priyadashini ma'am, and our beloved HOD ma'am, Dr. Punita ma'am. I am also take the opportunity to warmly welcome our resource person, Mr. Jagdish F. Pimple, for accepting our invitation and gracing this program with his valuable presence. Dr. Pragadish, Dr. Jagdish F. Pimple is a distinguished academician, researcher, and educator with over 18 years of teaching experience in the field of information technology at St. Vincent Pallotti College of Engineering and Technology, Nagpur. He has been recognized with numerous accolades, including the Best Performing Faculty Award 2024 to 25, Best Researcher Award, and recognition as a top mentor by NPTEL. His contributions to research are remarkable, with numerous patent, copyrights, book chapters, and international journal publications in cutting edge domains such as artificial intelligence, blockchain technology, machine learning, cybersecurity, and data science. He has also served as a resource person, session chair, reviewer, and mentor at various national and international conferences. Sir, your achievement, commitment to education, and passion for research are truly inspiring. On behalf of Mangayarkarasi Arts and Science College for Women, I once again extend a warm welcome to you, sir. We honored by your presence and eagerly look forward to your enlightening address. Welcome you, sir.
Thank you, ma'am. With immense
Thank you,
pleasure,
ma'am.
we now hand over the session to you, sir.
Okay, thank you so much. Just tell me my voice is clear and screen is visible,
Yes, sir. Your voice is
Yes,
audible
sir.
as well as the screen is visible.
and screen is also moving. Please check.
Yes, sir.
Is it moving?
Yes, sir. Yes,
Right
sir.
now?
Yes.
Okay. Okay. All right. Thank you so much for the confirmation. Okay. So good evening, one and all. First of all, I would like to thank that Mangayarkarasi College of Arts and Science for Women's Department of Computer Science and Applications for inviting me as a resource person for this FDP on AI-based advanced intelligent computing. Now we are on day 3, and today's topic of my presentation is a role of AI and blockchain in smart healthcare record management system. Starting with the presentations, these are the outlines of the today's session, the background and the motivations of the topic, objective, system architecture, and overview. Then we are going to see the role of machine learning in healthcare records, then machine learning techniques, ensemble learning, then role of blockchain in healthcare records, purpose of record mining, how blockchain works, integration of blockchain and machine learning in healthcare, and integration with emerging technologies and future research and opportunities for faculties. Now, what is the background and motivation for taking this particular topic, that we are going to use the concept of machine learning and blockchain in case of healthcare record management system? Nowadays, AI is everywhere. That everywhere we are listening about the AI, and in addition to that, nowadays we are listening about the blockchain also. So basically, why I have chosen this topic for this FDP, the background and motivation is just we are talking about the hospital, where how the records are managed. If you're talking about a traditional hospital record management system, nowadays we all are know. Whenever, suppose if you want to take a treatment from any hospitals or from any doctors, so we need to visit the hospitals physically. We need to tell our own history to the concerned doctor, and doctor will provide one file, where the doctor will hand over one file to the patients. That file contains some sort of a prescriptions. That file contains some sort of your health records. It may be of your pathology reports, or it may be of different types of reports that file it may be holding. Right? So for consider an example, suppose if I want to visit, if I'm suffering with the different 5 diseases, and we know whenever we are suffering with one particular disease, so we need to visit one particular specialist, right? So take an example, one particular patient is there, and that patient is having some sort of a diseases, and that patient regularly visiting the different doctors at the different hospitals. So suppose one patient is visiting the 5 hospitals, so he needs to carry the 5 different files. So it is very difficult for the patient. For example, if patient carrying 5 different files whenever he might be going to visit a particular hospital, and suppose if one of the file get missed out, right? If your file gets stolen out, so it is very difficult to the doctor, until and unless doctor, if he will not see your file, he will not see what he has treated or what type of medications or what type of prescriptions he has prescribed previously. So doctor were confused what type of patient, what type of treatment the doctor has given to the concerned patient, and what newly newly treatment or newly, what we can say, newly prescriptions that doctor needs to give to the particular patient. It is very difficult, right? So carrying the physical records in terms of files, it is might be difficult for every patient, because if it might be that particular patients visiting the different doctors for a different kinds of diseases. So why we are not making a system where we can create a file digitally, and that file is accessible to every doctor? It depends on the patients, that patients needs to give a access permission to the concerned doctor, that doctor can see the file of that particular concerned patients. So if whenever I will move from any hospital, there is no necessity or there is no restrictions at all. If I'm taking the treatment from Bangalore and if I'm shifting to Nagpur, right? So that Nagpur doctors is also going to see your history, whatever that your previous doctor has given, what type of a treatment. So if we'll create such a kind of system where we can use the concept of machine learning, and we have to use the concept of blockchain to secure the data of the patient whenever that patient data roll over on the network, right? So keeping all of these things in a mind, so I have selected this topic for the today's FDP, that why we are not focus or why we are not put a light on this particular topic. We have to use the concept of a machine learning or artificial intelligence along with our integration with the blockchain technology to secure the data, while creating such a kind of a unified platform for patient as well as doctor, so that any patient can move anywhere else, any doctors that patient can visit. So any doctor can view the patient history, how many doctors he has visited, what type of diseases he is having, what type of treatment he got till now, and what type of new medical prescriptions or new medical treatment that doctor supposed to give. So that patient history or that patient or total analysis of that particular patient, that doctor will get in a one single click. So that is only the motivations for selecting that particular topic. But the goal is creating a unified ML driven record system accessible from anywhere by both doctor as well as patient. Here we have the various advantages, or what we can say pros of this particular system, where we can remove the physical system totally, where doctor don't have to contain the physical file or don't need to create the print for the prescriptions and attach into the file, that everything will be in a digitalized format, right? So while creating the digitalized form, while creating the records, the security of that record is very much important. So to maintain the security of that particular data of any patient, because when we talked about the patient data is very much crucial, that we are not going to share any sort of patient data with anyone else. It is very much difficult because it is very much important that we are not going to share with anyone else. So patient data security is very much important. So that is one of the goal that that we are going to create a unified ML driven system where data get accessible to every doctor or every patient. That patient, sorry, not every patient. That patient can access his own data from the portal very easily on a single click. Now, what are the objectives of smart healthcare record system? We are going to develop a centralized or a decentralized, that if we are using a blockchain technology, so blockchain work on a decentralized manner. So we're going to create a decentralized online healthcare record system where data are stored in a centralized or a decentralized manner, that any patient can take his her own data on a single click, as well as he or she can share his own data with the doctors on a single click. Enable secure login and edit data sharing between the patient as well as the doctors, that we can share the login credentials for accessing the data with the patient and the doctors. We can use the machine learning for predictive analytics and anomaly detections. As we know, if we're talking about the data, if we're dealing with the hospital systems, if we're dealing with the medical management system or the record management system with respect to the medical, that predictive analytics related to the anomaly detection is very much important, right? So these things are used, or we can.
FDP. Sunil.
Is it am audible, madam? Anyone, please?
Yes, sir, audible, sir.
Yes, sir, audible.
Okay, all right. Thank you. So privacy and interoperability is very much important. For interoperability, we are going to use the blockchain technology for making the data more secure. Now, if you're talking about a system architecture overview of this healthcare record management system, so we have a 4-layer architecture. The very first layer is data acquisition layer, where we have to take the input from the patients, doctors, and various IoT health devices. As we know, nowadays, in the big hospitals are using the various IoT healthcare devices for accessing or sensing the data, and that data gets stored onto the server for further process. Then the storage layer, whatever data get created, the data gets stored into the clouds, or the transaction get recorded into the blockchain-based secure record management system. Next one is ML analytics. So in ML analytics, we have to use a predictive diagnosis, that we can use the machine learning algorithms to predict the level of the diagnosis of the particular disease, then health trends analysis and alert generations. For that particular purpose, we have to use a machine learning techniques. Then last one is the access layer. So with the help of web or mobile dashboards, we are going to access a patient, or we are going to access the data of a particular patient, that doctors can access the patient data as well. So these are the 4 different layers, or the 4-layer architectures that we can use for storing or storing the data of medical healthcare systems. Now, when we are talking about the machine learning in case of healthcare records, so as we already know what is the machine learning. So basically, machine learning is a field of AI that enables the system to learn from the data. So machine learning is nothing but that machine can learn something from the data which we are going to provide. And according to their learning, they are going to provide some sort of predictions. And this is most widely used technologies nowadays in case of a healthcare, in case of a medical system. Nowadays, disease detection. Suppose, for example, if you want to predict the level of the cancer, whether a particular patient whether a particular patient is survived with the cancer or not, that patient is having the cancer or not. So we can predict it with a particular data, right? So we have to use the machine learning concept, and we have to provide a different kind of data set to the particular ML algorithms, and that algorithm will predict the particular, if the particular patient record is having some sort of a symptoms and some sort of a, suppose with the help of their pathological histories and all. So we need to decide a particular patient is suffering with this so and so disease. So while using a machine learning, we have three different machine learning techniques. So we have a supervised, unsupervised, and reinforcement learning. As we already know that many of the participants knows the definition of supervised, unsupervised, and reinforcement. In short, I'll explain. Basically, supervised learning is what? So supervised learning basically work on a labeled data. It means that there are some labeled data, and on that particular labeled data, we have to perform some sort of a model. We have to create a model for labeled data. It means that a label is already given. That means we have already set of instances already given. That means we have an input and we have an output. There is a pair of input and output. It means that, for example, just take an example. Suppose if there are different images of the cancers, right? So already we have defined if the images will be look like, that means that particular image is a cancer affected image, or we can say that particular patient is having the cancer, right? So it means that we have some certain sort of a data sets where input and output already predicted. So we have to see, whenever we are going to use a supervised learning, we have a label data, right? So that means we have knows the input and we have knows the output as well. So we have to just check whether whenever we are going to provide such a kind of images or such a kind of data to the machine can directly provide a certain output related to your testing data, or related your test data. Second thing is your unsupervised learning. In unsupervised learning, we don't have any label data. So we have to find that model finds the hidden patterns, and based on that particular patterns or the grouping, that model will decide that particular image or particular data will be categorized in particular which class, whether it is on a 0 or a 1 class. That is when we work on a classification. So it means that that particular image is under the cancerous image or non-cancerous image. That means that particular patient is having the cancer or not having the cancer. So that means unsupervised, there is no label data, right? So according to the patterns, we need to predict the particular images, or we need to predict the data. And according to that, we need to take actions. Then reinforcement learning. So basically in reinforcement learning, it is a award-based or reward-based learning, where the model learns by interacting with an environment and receiving the rewards or the penalties. Basically it depends on the environment. Basically interacting with the environments, we need to give a prediction that particular images is a cancerous image or not. So these are the three different machine learning algorithms, machine learning techniques that we can use for a prediction purpose. After that, talking about the machine learning techniques, we have a different machine learning techniques with respect to their applications. Now you can say in classifications, we have a, suppose if you want to do classifications, so we have a random forest, we have a support vector machines. So basic application of RF and SPM is predict the diseases based on the symptoms. Suppose if the particular patient is having XYZ symptoms, and based on that symptoms, your algorithm should predict that particular patient is having swine disease. For that, we use the RF and SVM type of algorithms. Then again, we have a regression model. So we have to use a regression model. It is also used for prediction purpose. We have a clustering. So we have a group of patients with a similar health profile. Right? That means we are going to do a cluster. Suppose if you have a group of patients, and suppose if you have 100 patient data, and out of that, the 10 patient data or 10 patient images of MRI, right? That images are nearly about the same, right? That we need to prepare a cluster of that. We need to prepare a group of that. So it means that a group where we need to prepare a cluster, that is a group of patient cluster is having XYZ disease. That means if that particular image reflect on that particular pattern, it means that such a type of grouping will be considered a clustering. Then natural language processing, it is used to extract the info from the prescriptions and the lab reports. So many times what happens in natural language processing, here what we can do, there that already when we'll visit a doctor, doctor will provide the files, that file contains the prescriptions as well. So when it, even though when we do some sort of a test, suppose if we go the MRI test, that means if you do the MRI reports, CT scan reports, or suppose any your suppose blood reports, your CBC reports, etc. That means we have a n number of reports in a file. So when we do the scanning of that reports, and if you want to extract some sort of information from that particular report for performing set of some sort of a predictions, so for that we have to use the concept of natural language processing, because in one particular the prescriptions, when we scan the data, so data will be in the form of statement. So we need to extract the data. For that we have to use the concept of natural language processing to extracting the data from the prescriptions. Then anomaly detections, it detects the abnormal reading of a data or the errors. So these are the different machine learning techniques that we can use in the medical healthcare for predicting the data or predicting the images for a different kinds of diseases. Now, talking about the ensemble learning. Ensemble learning, it is one of the most widely used machine learning techniques. Ensemble learning, it is part and parcel of a machine learning technique. Now, the name itself represents ensemble learning. Now, ensemble learning and machine learning. For machine learning, we have to provide one particular model or one particular algorithm that we need to prepare a one model. And according to the prediction of that model, we need to take the decision. But suppose if you think for a result of one particular model, we cannot directly rely on that. If particular model says yes, particular image, when I pass the image to the model, when I give an input to the model as an image, and that model predict that yes, that particular patient is having the cancer. So you cannot rely on the particular model. That model has that particular patient as well as the doctors. So before sending the data to the patient, we have to see whether we are receiving the data from the correct authority or not, whether we are receiving the data from the correct person or not, whether we are getting the correct data or not. So for that, we need to do the classifications, right? That means we are getting the data from the correct person or not. So for that, we have to use the ensemble learning. That means we have to check whether we are getting the data from the correct person or not. So that is used, that classification is used for getting the correct data or not. After that, what is the role of blockchain? Okay. Now, talking about the blockchain, nowadays it is a very booming technologies in the market. So basically, blockchain means what, right? As you already aware about that, you already know about the cryptography, you already about to the steganography. That cryptography is used to convert your data in that means we need to convert into the uncipher form, and we need to send it to the network, and that receiver receive the data, and that receiver will decrypt the data. That is a normal process of cryptography, right? But again, the problem is the hackers can reach out your data, that introducers can reach out your data. But the new technologies was invented in 2009, that is blockchain, right? Basically, it was came into the picture in 2009 by Satoshi Nakamoto. That is an anonymous person was introduced this particular technology called as blockchain technology by Satoshi Nakamoto. So in 2016, that particular technologies was came into in existence, because the first paper was first first white paper was printed by the Satoshi Nakamoto on the blockchain. So basically, blockchain, it is used to store the data in high security form. That means none of the person, none of the hacker, none of the AI hacker, or none of the introducers will breach out your data while data get travel over on the network. That is the main concern of blockchain. Before traveling the data, before sending the data, that data get verified, that data get mined by the miners or validators, then and that data get stored onto the blockchain, and once the data recorded to the blocks, so we cannot modify the blocks. So basically, whenever we'll use a blockchain technology, so blockchain have a different functions or different features. The very first one is data security and integrity, where the records are stored in tamper-proof blocks. That means whenever we are going to store the data into the blocks, basically blockchain is a collection of blocks, block and chain. These are the two different words. Block, where we are going to store the data or a transaction, and that all blocks are connected together through a chain called as blockchain, where every block is having one unique hash value, or every block is having one unique hash value. So every block is connected to each block. It means that every block contains the hash value of previous block. You might have learned about the linked list in case of data structure. I think if the faculty members are belonging to the computer background and they have learned about the data structure, so in data structure we learn about the data linked list. So in case of linked list, every node contains an address of another node, right? But in blockchain, every block contains the hash address or a hash value of a previous block. That means when you can see in the diagram that block 1, block 2, block 3 till the block n minus 1. So every block is connected with the chain. Every block is connected with the hash value or the block address. It means that if any hackers try to breach out with the one particular blocks, so all block get affected. If the particular hacker trying to reach out with one block and try to break out the hash value or the address of one particular block, so all other connected subsequent block get automatically disturbed. So we can easily identify, yes, the what we can say, the hacker is tried to breach out the address, try to breach out this particular data on this particular block. So there is none, that means what we can say, there is no ways to hack the data from the block itself, right? After that, decentralization, it is one of the blockchain properties where data are stored in the blocks. So decentralization is there. When we talked about a centralization, so or a server or a cloud, so where all the data are stored in a one cloud or a one server. So if that server get hacked, if something happened with that server, your whole data get collapsed, right? But blockchain work on decentralization. That means your data is present in all the blocks. That means blockchain work on peer-to-peer networks, right? So it means that where peer-to-peer, every nodes are connected with each other. So all data are available with every peers. It means that if anything happened with one peers, so your copy of every data is available with all the peers. And there is no possibilities any of the hackers cannot breach out your data, cannot try or cannot modify or take your block address from the particular block. Then transparencies and the privacies. Talking about the transparencies, so blockchain is basically known for transparencies. It means that whenever we store the data into the blockchain, so every person or every member of the blockchain knows everything which data is stored into the blockchain, right? It means that there is a transparency. That means we cannot take a that means we cannot not hide anything from anyone else. That means everything knows everyone. That means suppose if the patient data is there, so the miners exist in the blockchain. So if you are storing the data, so your miners know that data is added into the blockchain. There is no hidden policies. So that's why blockchain basically known for transparencies and the privacy. Then interoperability. Blockchain enables the seamless record sharing across the different hospitals and the clinics. So once a data you have created the blockchain, the data can use or data can be utilized by different hospitals and the clinics. Patient-centric ownership. That patient can control his own data. Suppose if I'm a patient, I want to think if this particular data I want to show to my doctor, that data I can show. Like if the particular data I don't want to show to my concerned doctor, so I can preserve the data from seeing that particular data from the doctors. And auditability, every access or update is permanently recorded. Once the data gets stored into the blockchain, we cannot edit the data. So auditability is heavily, that means what we can say, auditability is one of the feature of blockchain. Okay. Now, what are the different types of blockchain? We have to use a public blockchain, private, federated, and a hybrid blockchain. Now, talking about a public blockchain. So, as I already told you, if you're talking about a blockchain, in blockchain, any data you have recorded, any transactions you have recorded, everyone know everything. There is no hidden at all. So, public blockchain, anyone can be the member of this blockchain. It is a free access. There is no permission required to store the data. That data is in the form of shared ledger and full transparency is there. There is no hidden things. Private blockchain, for example, if I'm having my own hospital and I need to create a blockchain for my own hospital only, so I have to create the private blockchain. So it means that the member of the particular, that is member of my own hospital or the particular, what we can say, the person belonging to my hospitals, they are the member of my blockchain. It means that a private blockchain means it is private. It is exclusively designed and developed for the one particular hospitals. In case of public, that any hospital can access the data, but in case of private, that private blockchain is exclusively created for the concerned hospital. After that, talking about the federated blockchain. So in federated blockchain, so there are different hospitals are there. Suppose hospital X, hospital Y, hospital Z. And I want to share a data between X, Y, Z hospitals. So X, Y, Z hospitals are not going to share a data. They are going to share their own patterns with the blockchain. That they are restricted with the data. That means, for example, I'm belonging to the hospital A. I'm the member of hospital A. So I'm not going to share my own data. If I am doing some sort of a machine learning analysis or a predictions on diseases, on some sort of a certain images, so what I'll do, I'll share my results with with some other hospitals, but I'm not going to share my actual data with anyone else. Right? The last one is hybrid blockchain. So basically, hybrid blockchain, it is a combination of public and a private blockchain, where we can have a features of public as well as a private blockchain. Right? So these are the different blockchains that we can exclusively create for hospitals. We can create public blockchain, else we can create private or hybrid or a federated blockchain. Now, what type of network architecture the blockchain use? There are two different architectures, as we already know, a server-based network and a peer-to-peer network. So your blockchain always use peer-to-peer network. Blockchain always use peer-to-peer network because it uses a decentralized, because every peer are connected with each other. It means that your data copy of every block is available with every peer, right? So if any intruders or the hackers trying to reach out one particular peer, so all other peers get affected, right? So that's why the decentralization, right, in the blockchain, it is very much powerful. But now in case of server-based network, that if you're talking about a client-server network, so all data are stored in the server. So if something happened with the server, your complete data get collapsed down, right? So that is the main drawback of the server-based system. So that's why blockchain uses a peer-to-peer architecture. Now, what is the role of hashing? or cryptographic hashing function in blockchain. Suppose now I have a patient record, I have a prescription of the patient. So what I'll do, I'll scan the prescription, and for that particular prescription, I'll generate a hash function. I'll generate a hash value. So basically what it means a hash, right? So it means that you have a message. Say for example, you can see on the screen, there is a hello, right? So for the hello, I'll generate a hash function. That hello is given, that hello is a digest. The digest is given to my hash function. So what will generate a hash values for the hello. So whenever that particular message is given to the hash function generator, it will generate a 128-bit hash value. So for any size of message, it may be of hello, it may be of any image, it may be of any audio file, it may be of video file. Your file size may be different with respect to your size, with respect to your anything else, dimensions and all. For every digest, we have to generate a 128-bit hash value. So for every message, we need to generate a hash value, and that hash value we need to travel that particular data when we send from machine to machine or from one machine to another. So we have to send in the form of hash value, and the data get also stored in the form of hash values only. That's why we are saying blockchain is more secure rather than your other security algorithms, right? So what are the cryptographic hash function that we can use, right? So in case of a hash function, there are different hashing algorithms are available that you can see here: SHA-224, SHA-256, SHA-512, and KICAC. These are the different hashing algorithms that we can use to generate the hash value. Suppose, for example, suppose if I'm having a message and I have used a SHA-224, so it will generate the 224 hash value. SHA-256, it is generated 256-bit value. SHA-512, it generated 512 value. 12 bits in the hash, right? So it means that if you're talking about the hash function, so hash function always generate the hash value for any kind of message. That message itself, it is called as a digest, right? So just see on a diagram, you can see that how hash value will get generated. Suppose if you have a number data, suppose if you have a text, suppose if you have a images, suppose if you have a videos, suppose if you have an audio file, right? So you can send any file, any data as a message. Your message itself, call it as your data, right? So data is given to the cryptographic hash function. You have to apply the hash function algorithms. So you have to take a input as an image, text, number, or video file, or any audio file. It is given to the cryptographic hash function. Cryptographic hash function will generate a 128-bit hash value, right? What it will do? It will generate a 128-bit hash value for the particular message, or that particular hash. It is also called as digest, right? So there is no restrictions with respect to your size of the data. So suppose if you have a text file, we have a text file of 1 GB, right? So for 1 GB data also will get the same 128-bit hash. Suppose if you have a message simply hello, right? For the hello message, you have a 128-bit hash value. It means that I'll request the participant, can you please mute your mic? Please mute your mic. Okay, all right, thank you. So for any kind of messages with respect to any size, it will generate a constant 128-bit hash value, and that hash value importance is more in blockchain. So for generating the hash values, we have a different online platform we can use for generating the hash value. We have a pre-formatter, we have an online web toolkit, we have a text tool suite. These are the different platforms that we can use for generating the.
Excuse me, sir. Dear participants, mute your call. Sir, mute your call, please. Mr. Sindel, sir.
Okay, all right, thank you, madam. So there are different platforms that we can use to generate the hash function. These are that already implemented platform, already algorithms were implemented that we can directly use to generate the hash values for a particular messages, right? So it means that your data size, it may be different with respect to size, but your hash value should be of constant. It totally depends on the type of hash functions you are using. Suppose it is 128 bit, so you get 128 bit hash value for every messages, right, with respect to of any size, right? Suppose if you have a video file, you'll get 128-bit hash value. You have an image, again you'll get a 128-bit hash value. You have a text file, you'll get a 128-bit hash value. Forget about the size of your data, right? So, and likewise, we have to generate the hash value for the different datas. Now, what is the purpose of record mining, right? So, why we have to do the record mining? When we talked about the blockchain, so whenever we need to store the data, or when we want to travel the data over on the network, and that data gets stored into the blockchain, we have to do the validation of that particular record. It is very important. So without validation, without mining, none of the member of the blockchain are going to store the data into the blockchain. Validation is very important part. To authenticate the data, that means we are storing, we are getting the correct data or not, we are getting the correct patient record or not. We have to check the authenticity of data, validate the data, and then the data gets stored into the blockchain, or we can say in block. Adding the transaction in the block, we have to use a consensus of mechanisms like POW, called as proof of work, proof of stack. That again, there are different types of mechanisms are there. That is a proof of burn, proof of activities. These are the different consensus mechanisms that we can use. In short, we can say these are the agreement between the users, right? So we have to use these consensus mechanisms. So basically, to validate the data or a record, these consensus mechanisms need to be used for validations of the records, right? Now, what is the work of proof of work, proof of stack? These are the consensus mechanisms. So basically, when we are using a blockchain technology, so we have to use the consensus mechanisms. When talking about the consensus mechanism, so when the blockchain was introduced in 2016, so at that time the Bitcoin blockchain was there. So Bitcoin blockchain heavily used the proof of work, called as POW. And afterwards, when the Ethereum blockchain came into the picture, so Ethereum uses a POS, called as proof of stack. It is a mechanism, right? It is an algorithms, or what we can say, it is agreements, right, that we need to use, right? So basically, how POWs, proof of work, how it works, right? Suppose if I want to store one data into the blockchain, so what I need to do, I need to initiate a transaction, right? So once the transaction get initiated, that transaction need to float in the complete peer-to-peer network, right? So that one transaction floated over the all P2P network, that all miners received the transaction. Then what miners will do? Miners will try to mine the data. Miners will try to solve the complex mathematical puzzle for that particular transactions. That means they're going to validate the transaction. They're going to see whether that we have received the correct data or not. So out of that 100 miners, for example, in my blockchain, we have 100 miners. So that transaction, that data float over onto the P2P network, that all the 100 miners received a transaction. And all miners are trying to solve the mathematical puzzles for mining the particular transactions, right? But out of that, whosoever the miner mine the transaction or validate that particular transaction, that miner will get the reward points. And once that transaction mined, so every miner will check the validity of that data. We need to mine that data, mine that particular data, right? So it means that in proof of work, lot many computation power required, because all miners are started working simultaneously to mine the one transaction. And out of that, one miner will get a success. Out of that, one miner will get a reward. But other miners are not get anything else. So their computation power is going to be best, right? So that is the drawback of POW. So when Bitcoin was used, so at that time POW consensus mechanisms used, right? So that is the work of POW. So similarly, we have to use another consensus mechanism called as proof of stake. So basically, what it means, a proof of stake. So in proof of work, all manner work simultaneously. But in proof of stake, what it will do? In case of Ethereum blockchain, so POS is a mechanism or a consensus mechanism where the miners, in case of POS or Ethereum blockchain, that miners name get changed called as validator. In Bitcoin, it is called as miners. In Ethereum, it is called as validators, right? So what it will do in Ethereum blockchain, when we will use a POS called as proof of stake, all the validators put their own cryptocurrency on the stack, right? Suppose if there are 100 validators, so what 100 validators will do? They will put some cryptocurrency on a stack, right? And out of that 100, one of the validator will came. That means one of the validator will be what we can say we shortlist, or we can give a responsibility to that particular validator to validate the transaction, right? So instead of giving the chance to all 100 validator, we have to give a chance to only one. So it means that only one validator start working on that, and that particular validator is going to validate the transaction. That means all other 99 validators are idle. It means that the competition task required for POS is very less, because only one validator is going to validate the transaction. Other validators are as it is, they are just going to check whether that particular validator validated the transactions properly or not, right? So that was the people are using POS called as proof of stake. Basically, it is used in Ethereum blockchains, right? And once that particular validator validate the transactions, so it means that that validator will get the reward points in the form of cryptocurrency. So it means that in case of healthcare record management system, once data get roll over on the network, suppose if one prescription of patient is there, and I need to store that record, I need to store that patient record into the blockchain. So how that particular patient prescription gets stored into the blockchain, we'll see through this particular process. So first of all, we need to initiate the transaction. That the first step is, as you can see, first of all, the very first point is transaction is requested. You have to request for the transaction. Suppose I want to store one patient record in blockchain, so we have to request for the transaction. Then once you created a request, your request get created for a one particular block. Once the request created, that transaction is sent all over the network. You can see in the phase 3, that request is floated over on the P2P network. That means that request is given to the all network. That means all the peers will see what type of transactions are entered into the network. Now in the fourth case, we have to validate the transaction. That means suppose if we are using a POS, that is proof of stake, so any one validator will validate the transaction. But if we are using a POW called as proof of work, so all peers are start working on that, all miners are start working on the mining process, right? But it is depend on the type of blockchains you are using, and it is depend on where you are. It is depend on the depend which type of consensus mechanisms you have used in your blockchain, whether it is POW or POS. Depends on that, the validation will be happened. Once the transaction validated properly, that means yes, this particular data is correct one, right? So that data get added into the existing blockchain and your transaction is complete. In between that, right, here we are going to just validating the transactions, right? But how you can validate? Suppose if you created the blockchain for hospitals, right, and I am transacting the record of one bank, right? I am doing the financial transaction. So I am working for, I am creating the blockchain for the healthcare records, but I am transacting the financial records, or I am transacting some financial transactions. So it violates the conditions. So for that we need to check whether we are getting the correct record or not. So for that we have to use the concept of machine learning, right? Whether we are getting the actual healthcare related data or not. So that will be checked with the help of machine learning. So in the next, we need to see online health record system. So you can see we have a patient, we have a doctors, we have a data acquisition there. We need to access the data from the doctor and the patients. We have a ML analytics. We have to use ML analytics to check whether we are getting the healthcare related data or not. We have a storage layer. for storage purpose because we need to store the data, but the transactions always recorded into the blockchain. There is access layer to access the data, so we have used web-based desktop, or we can use the mobile dashboards for accessing the data. So this is actually the architecture or block diagrams that we can use for record management system. Now, how we can integrate the blockchain and the machine learning? As we already told you, blockchain basically used for to secure a data, and machine learning it is used to classify the data, whether your data belongs to the healthcare or not, whether your data is correct or not. So that means classification will be happen with the help of machine learning. And blockchain it is used for storing the data, or blockchain basically it is used to enhance the security of your data. So we have to club together, we have to integrate blockchain with the machine learning. So we have to create a high, what we can say, that high secured system where we can secure the patient record and store in a decentralized manner, so that any doctor can access a data from anywhere on a single click. Patient can see his own data at any place on a single click. That the patient don't want to carry his own patient file or multiple files with the patients, or even though patient is also don't have to worry about the previous or the past history of the particular patients, right? So when we club blockchain and machine learning, so we'll create the high security system where we'll create a unified model. On a single click we can access the data of the patient through the doctors as well as through the patients, right? After that, blockchain applications in healthcare. So what are the different applications of blockchain, right? So we can use the blockchain for clinical records, managing the clinical records, for predicting the diseases that we can use. Different universities, research universities, that they are working on the different projects of health related, they can use the blockchain. Different government industries, different insurance companies that also can use the blockchain. Different research institute that you can use the blockchain, right? So the blockchain that can be used for a different kinds of sectors, even the financial sectors, fintech sectors, educational sectors also can use the blockchain for creating a secured and highly secured model, highly secured system where data are stored very securely. Now, what are the various key features? Suppose if we have developed the particular this system, so what are its key features? So there is a unified login system for doctors and the patients. The doctors can access the patient data from his own login. Patient can access the data through his own login. Then automatic medical records update. The patient and doctor can automatically update the records. Then smart search and summary using NLP. We can use the natural language processing to extract the data from the patient prescriptions and store it into the blockchain through the clouds, right? We can use the AI-driven healthcare insight and alerts. We can use the AI systems for the healthcare insights, for finding the insights and the alerts, right? We can use a role-based access control. That means we can give the access permission depends on the level of the particular member of the blockchain, right? We can use a data visualization dashboards, that we can use the dashboards, right? So on dashboards, we can display that particular patient is connected with how many hospitals, how many diseases he is having, right? That means patient history, patient login history. That means different things, different history of a particular patient that can be visualized on the dashboards, on the patient as well as the doctors, right? Now, what is the workflow? If we're talking about the workflow of the particular system, so we need to create the user and the doctor's login, or we can say credentials. We have to upload the data of health records, IoT's data, and the reports. All healthcare related data we can upload in the login of patient as well as in the login of the doctors. Then we have a ML engine to process the data. We have to use the machine learning algorithms to authenticate the data, whether we are getting the correct data from the correct person or not. So we have to use a ML engines. We have to use the ML algorithms. We can use to generate the predictions and the alerts. Let me suppose, for example, I am a patient and I need to visit doctors after 15 days. So I'll set the alerts, right? So that after 15 days, automatically on dashboards, we'll get a link, we'll get a notification. Yes, you have to visit, right? Suppose something, my health checkup is there. My suppose let me some pathological reports, pathological uh, testing is need to be happen in every 15 days or in every month. So we can set the alerts for that as well. We can also display our results on the dashboards, right? So this is actually the workflow. After that, integration with emerging technologies, that we can use the different emerging technologies for integrating blockchain and machine learning. So we can use the IoT wearable for real-time monitoring. We have to use IoT wearable devices. Suppose we have a wearable gloves in a hand, right? So that it can be used for real-time monitoring. So we have to integrate the machine learning with IoT for a different kind of purposes, right? We can use in blockchain for secure health record sharing. We have to use a federated learning for privacy preservation. But that means if we are using a federated learning, so the meaning of federated learning means that blockchain is different and a federated learning is different. In federated learning, the learning will be at the local site. Suppose if there are different hospitals, so in different hospitals they will do the learning, they will develop their own model, they will train their machines at their own local space, and they will share only pattern with the other hospitals. They will share the results only. What is federated? They're not going to share the data of any patient. They will share the results. They will share the patterns only, right? That means the federated learning. Then cloud and edge computing for scalability. So nowadays, edge computing is one of the booming technologies that the many of the devices are using the edge computing, right? So cloud and edge computing for scalability that we can use, right? Then the future research and opportunities for the faculties, that we can use the explainable AI for health. We can create the explainable AI. We'll create the edge ML for wearable devices. We can use the agentic AI for smart hospital management system. Then opportunities for interdisciplinary research like CS plus healthcare. That means we can use a different, and what we can say, different computer scientists or different computer engineers, that they are going to work on a different healthcare related projects for the prediction of diseases and other things. So that we can use the interdisciplinary research work as well. And the collaboration model, that different industry, different hospitals, different universities, different research center, that they can collaborate their work together for generating the models for predicting the different diseases. So we have a different research, what we can say, research opportunities for the faculties as well as industry, and for the research institute and the research universities. So all of these are the opportunities for the faculties. So with this, I think the participant gain some insightful things through these particular sessions, right? So if participants have any questions, so please ask me.
Dear participants, if there is any query, please pose your queries.
Good evening, sir.
I'll request anyone, please take us some screenshots and please share with me.
Good evening, sir. My voice is audible to you.
Yes, ma'am.
Sir, I
You're a
have
little
one
bit
doubt.
low. Please, little bit louder, please.
Sir, I have one doubt.
Yes.
In machine learning, the models are used for predict the data. So in the blockchain layer, what is the purpose of POS and POW?
In machine learning, basically it is used for prediction purpose. That will do the classification. Just I have given the example, I quoted the cancer example, that images, right? We have a data set of images, right? And we need to predict that particular image is cancerous image or not, right? But once that particular image we have classified properly, then that data get recorded into the blockchain, right? So it means that when the record, that I'm talking about the data set, that means images, right? So if we talked about that, we can integrate that, we can relate with any sort of application. For example, if one particular patient prescription is there, right, and I need to store that prescription into the blockchain, So first of all, we need to check the authenticity of that particular prescription, whether I am getting the correct data from the correct person or not. Because when that data travel over on the network, suppose that prescriptions I'm going to send from one machine to another. So in between that, if data breaching happens, so if any hackers modify that data, right, and you don't know that there are some changes with the data, right? So we have to see the classification. That means whether we are getting the correct data or not. That means we have to check the authenticity, and we need to do the validation in blockchain. Authenticity will be checked in the machine learning. We have to do the classification. We are getting the medical related data or not, right? And in the blockchain, we have to do the validation of that data. And once it is validated, then the data get recorded in this blockchain. So machine learning basically used for classification, and blockchain it is used for to secure that data. That means whatever data will send on the network, so that data is not breached by someone else. That is the main purpose of blockchain, right? Got it?
Yes, sir. So that it is mandatory to use a POW, POS in blockchain layer.
Yeah, it is obviously mandatory, because these are the consistent mechanism that we can use, right? Because without POW and POS, that means how validations we can do, right? So we can, when you club machine learning and blockchain, so instead of using POW, you can give a POW work to the machine learning, because POW itself it is doing the mining process or validation process. So if we are using a cryptocurrencies and all of these things, in case of a cryptocurrencies, so at that time POW and POS you can use, but you can replace POW and POS with the help of machine learning algorithms. So machine learning will do the mining process as well. You can say in short, right, that machine learning basically used for mining process or validation process, right? Got it? So it is depend how you are going to integrate blockchain and machine learning, or only you are using a machine learning and a blockchain for simply data storage, or simply for securing the data of fintech or educational system. So that depends on you which type of applications you are developing. I hope I have cleared with you.
Okay, sir. Thank you. Thank you.
Thank you, sir. Other
Thank you.
participants, do you have any queries? Shall we end this session? Thank you, sir, for your inspiring and knowledge-rich presentation. To express our gratitude, I now invite Ms. S. Alaguparvati, Assistant Professor from the Department of Computer Science, to deliver the vote of thanks.
Thank you, ma'am. Good evening to everyone. It gives me immense pleasure to propose the vote of thanks for the successful completion of day 3 of our faculty development programming. On behalf of all the participants, I would like to extend our heartfelt gratitude to our esteemed resource person, Mr. Jagdish, for conducting today's enlightening and interactive session. Your expertise, valuable insights have made today's programming highly informative and beneficial, sir. And I express my sincere thanks to our management principal for the constant motivation and support in organizing this faculty development programming. And my thanks to organizing committee faculty members. Once again, I extend our thanks to Mr. Jagdish F. Pimple, sir. Thank you, everyone.
Dear participants, thank you all, and let's meet you all in the day 4 session. Thank you.
Thank you so much. Thank you so much, all the participants. Thank you so much to organizing team for inviting me for delivering the sessions. Thank you all. Have a nice time ahead. Thank you.
Thank you.